Alright, so this is going to be a fairly quick tutorial on setting up the Pico SDK in the best way possible. So we're going to jump right in. First thing we're going to do is we're going to download the ARM GNU toolkit. This is the easiest way to actually build the files for your Pico. And this compiler is required for building anything for ARM GNU compatible devices, such as the ARM M0 Plus on the Pico. Next thing we're going to download is MinGW. Now, the Pico SDK recommends that you use nmake, but MinGW is just painless and it does not require you to download the Visual Studio Toolkit from Microsoft. Which also means that you won't have any sort of issues with, compatibility between it and like the Windows SDK if you're developing for Windows as well. So here we are. We're installing the GNU ARM toolkit, and in the background you can see that I am also downloading some of the other requirements, such as CMake. I'm going to keep downloading things, but I'm going to install them one by one. By the way, I just want to let you know, all the links will be in the video description below that you will need for downloading this toolkit. Also, I will provide a couple of the commands that I use as well. There's very minimal command line usage in this, but I do use a little bit. So it's real important here that you add the path to environment variable for the ARM embedded toolkit. We'll have to make some adjustments later on, and you'll see that in the video here. Okay, so next we're going to be installing MinGW. So you're just going to use the default settings here. Now, I chose to install this in a different location just to make it a little bit easier to add it to the path later, as well as some edits that we're going to need to make to it. So we're going to create a folder on the C drive called Pico-Tools, and then we're going to create a folder inside that called MinGW. Now it's going to download everything that it needs and install it all. Now while that's working, we are going to go ahead and open up the File Explorer and head over to the directory which that is installing. Take just a moment for that. I am doing this as I'm recording this as I go, but I am doing a voiceover because it's a little bit easier. So here we go. Now we're going to let it finish the install, and then right afterwards we're going to just make a copy of a file. Super simple. You'll just have to find the file in this folder. I'll show you that in just a moment here. So we're just going to hit next, then finish. We're going to go into the MinGW32 and into the bin folder. We're going to find MinGW32-make. And we're going to make a copy of that. And and we're going to rename that copy just make. So once we've done that, next step is to install CMake. We want to add CMake to the system path for all users. Go ahead and install it in the default location, that's totally fine. And while that's installing, we'll go ahead and start downloading Python. And then we'll download Git as well. CMake is done. We're gonna grab Python. Add Python 3.9 to path. That's very important that you put that in there. We'll hit install now. And as soon as it's done installing, there's an option right afterwards that can disable the max path limit in Windows. Do that. You'll see it here in just a moment. Disable path length limit. Click that, hit yes, and then close the setup. Next we're going to install Git. I know this is a lot. A lot of folks have looked at the Pico SDK and been like, wow, this requires a lot of extras. Don't worry about that. You can see we're 7.5 minutes in. We're already, almost done installing the tool chain that's required. So we're just going to kind of fly through the setup here. I did for a moment here try to set the default editor as Visual Studio Code, but we don't have it installed yet. That's totally fine. We don't really have to set this to anything. I'm familiar with Nano, so we're just going to go ahead and leave it at that. We're going to let Git decide. Now here I'm just reading through the options. I had already had Git installed on my main machine. I don't know if you've noticed, but this is being recorded in a virtual machine. So I am just kind of reading through the options here to make sure. But we are going to select the default option pretty much all the way here. Everything that's already set up, just keep on clicking next. And install. Pretty quick installer. We're going to go ahead and hit finish. And we're going to download Visual Studio Code. Visual Studio Code really is a great text editor. Now you're going to want to add these options so that you can open with code. It just makes things super easy. You can just right-click a folder, open with code. You can right-click a file, and go ahead and make sure that it's selected that you add to path. Path is a pretty important environment variable for all of this stuff. So we're going to want to make sure that we add a ton of this stuff into path. So next thing we're going to do is we're going to create a folder. We're going to call it Pico. This is on the C drive. That way we know where it is. I don't really want to use PowerShell for this. I want to make it simple, so we're going to open up the command prompt. See, I'm struggling here. I kind of left a note to myself to edit that part out. Doesn't really matter. But we have our open command prompt. We're going to go ahead and hit git clone b master and the path to the SDK. Don't worry, these will also be in the video description, the commands needed. And what we're doing basically is we're checking out the SDK and we're making sure that all the submodules are checked out as well so that they'll be available. Next thing we're going to do is we're going to go ahead and grab the Pico examples as well, so that we can build all the examples, which will also build the SDK as it goes. And you can see it's all downloads pretty quick. It may seem, you know, like quite a bit of stuff, but we're only 13 minutes in and we've already got everything required to get going on this. The next step is just to install a couple extensions to make things easier inside of Visual Studio Code, and we'll be good to go. So we're going to go over to take a look at the Blink code. But first thing we're going to do is we're going to go to extensions. We're going to install the C extension. This is for C and C++, and then we're going to look up CMake and install the CMake tools extension. Now, you're going to want to click on the gear icon and go to extension settings. We're going to configure environment, and we're going to add Pico _SDK _path, all capitals, and then we're going to set it to the path that we installed the SDK, which, if you're following this exactly, is C drive /Pico /Pico-SDK. We're going to hit OK to save that. And we're going to go to CMake generator. which is right here. We're going to type MinGW, find the capital letters, make files. You also need a capital M there. MinGW make files. Now here you can see MinGW search ders. This is for our directories. We're going to want to edit this. Double click it. And we're going to grab the directory where we installed MinGW in Pico Tools. And we're just going to copy the first part, or the last part there, because the system drive variable will automatically pick up that it's C drive. So we're just going to look in C drive, Pico Tools, MinGW. It looked like an update to the C++ tools that appeared right when we were working on that. So next we're going to go ahead and go to search in the start menu, search for environment, and you'll see edit environment variables. We're going to find our path, and we're just going to add a few things to path. So first thing we want to add is we want to go to MinGW, MinGW32/bin. We're going to add the full path into our path environment variable. And the easiest way to do this really is just to find the tools that you want to add to path, and then copy it from the address bar, paste it on into the path. So there we're adding the ARM GNU embedded toolchain. We want to go to the bin folder again, and then we're going to add CMake as well. Bin folder. Bin stands for binaries. So next thing we're going to do is we're going to just make sure that all of those are also available in the system environment variable for path. So we had CMake in there, that's fine. We just have to copy over the MinGW and GNU ARM. Now that all looks good, we'll go ahead and hop back over to Visual Studio Code. And we're going to close it, reopen it back up, that way it can pick up the most recent path. I remember I had you add that option to just right click, so we're going to just go into the Pico examples, right click, open with code. Now, it's going to ask you if you want to configure. Just hit yes. It'll do a pop-up at the top to ask you to select a kit. You want GCC 10.3.1 ARM None EABI. You can see it down at the bottom of the screen in that blue bar. Next, we're going to click on the CMake icon on the left, and then we're going to hit the top button, which will configure our project. Once it configures, it'll populate the CMake window, which is the left bar. There it is. And then we'll just go ahead and hit build all projects. This part can take a while. So I've gone ahead and sped up the video here. I believe this is playing back at 8 times speed. This did take me a little while, so this is the part where you know, you're going to be sitting for a minute. But what it's doing, it's building not only the examples, but it's building the SDK required for any of your projects as well in the background. So it's doing all of that at once. But with the magic of video editing, you see I cruised right along, and here we are at just the end of the build. And you'll see build finished with exit code 0. That's what you want to see. It means that everything built perfectly. So now that you've done that, you can see the build folder has appeared. That's going to have all the binaries in it. And all your UF2 files will be in the folder corresponding to the project that you built. Now the next step is to create your own project. To do that, we're going to just create a new folder. Here I'm doing it on the desktop. Doesn't really matter where you do it, because now everything's been configured. I'm going to name it Pico Project, and we're going to open that folder in code. So I'm going to go ahead and I'm going to open the SDK and our project side by side. We're just going to need a couple of little things from the SDK for setting it up. So first we're going to do Pico _SDK _import.cmake. That is the first requirement. And we can literally just select all, copy paste this from the Pico SDK examples over to our project. Save that. And then we're going to make a new file. We're going to call it CMake lists. Now it's really important that you have the capital letters where they're required. So capital C, capital M, capital L. And we're going to do CMake lists.txt. Now we're going to need a few things from the Pico examples. Minimum required, including the Pico SDK import.cmake, and then set some of the project stuff and set the C and CXX standards. We're also going to need Pico SDK init, and we're going to add a subdirectory called code. You can see that I added a folder in there. So in our folder, we're going to make another CMake lists.txt file. We're going to fail to edit it and go ahead and create our blink.c++ file, or CPP. And we're going to kind of just like copy some of the code over, but who likes to just copy actual code? It's so much better to type it. Now, you might notice that this is a CPP file and the examples use C. It's going to build the same regardless. It's really more what you're comfortable with writing in. So you can see that I just put GPIO init 25. That is what the Pico default LED pin variable is set to, what the define is set to. I would just rather type out 25 than put that in here. even as a variable. It's just simpler for me, and this is a simple example. So we're going to set the direction to output for pin 25, and then we're going to do our basic blink example here. Now you might notice that IntelliSense is not actually picking up any of the default functions from the SDK. Don't worry about that. The first time that you configure your CMake, it's going to pull the SDK, and it's going to know all that stuff, and you'll be able to use IntelliSense and get all the info from the SDK itself. So, and you'll see, you know, it's not going to know what the Pico/standard library is. Don't worry about that. Once you've ran CMake for the first time, it's going to work. So next step here is we're going to use Control-Shift-P. That's going to open up our options menu up here. And you're just going to type CMake and select CMake configure. You're going to select the same thing as before, GCC 10.3.1 ARM none EABI. You're going to configure and you're going to build. And you notice it didn't quite build properly. It didn't build any UF2 files. It didn't build anything in code. Main reason for that is because we did not actually edit our CMake lists.txt file. Gotta make sure that that's there, because that's how it is configured to do everything. So we'll take a peek back at the SDK and look at the CMake list file for Blink. Only need a couple of things here. We just need to add an executable. The name is going to be code, and then the file is going to be blink.cpp. We're also going to need to link the library. So you're going to go target link libraries. Code is the name of our project, and we want the Pico_standard library. And then we want extra outputs so that we actually output not only our UF2 file, but a few extra outputs that are really useful for debugging, including disassembly. So once we save that, we can hit build, and you can see it's actually going through and building things from the SDK. It's linking everything together, and we have build code 0. And if we look here, we've got our code.uf2. It's going to be pretty much identical to the Blink example when we drag it over to our Pico. So, thanks for watching. That is it for setting up the Pico SDK and for setting up your own projects.